Okay, so far in this chapter, we've found solutions by finding square roots. On Thursday, we completed the square, and yesterday we used the quadratic formula. Another way of breaking down quadratics is to factor them. And so before we can do that, and we'll do that tomorrow, we need to review factoring. So we have this factoring review, which can serve as your notes, and then you can use this to complete the worksheet that goes with it. Okay, greatest common factor is the first one. You're going to use this when nothing else looks like it'll work. It's not difference of squares. It's not a trinomial of any kind. So it's ugly enough that we'll use the greatest common factor. We're going to look at each term carefully and see what we can divide both terms by. So it looks like both terms are going to be divisible by 3, so we'll pull out a 3. Both terms have x's, but one at a time is the most it has, so we'll divide it by 1x. And then we have 1y here and 2y's here, so we'll divide it by 1y. If we had y squared and y cubed, then we could divide it by y squared, but you can't divide it by more than you have. Okay, so we've got 3xy and 3xy, and we're going to divide those. Whatever's left goes in the parentheses. So I'm going to cancel out my 3's. I'm going to cancel out one of my x's and both y's. So in the first term, I have an x. In the second term, my 3 can be divided in the denominator, leaving me with 1, and in the numerator, leaving me with 4. I'm going to cancel out both x's and one of my y's. And so I'm going to be left with plus 4y. And that is going to be the solution to this polynomial. Okay, the next one. Next one looks like it should be difference of squares. This is a perfect square. X is squared, but that 5 is not a perfect square. It does go evenly into both of them though, so we're going to pull that one out. We're going to divide both terms by 5. And whatever's left goes in the parentheses. So 5x squared divided by 5 leaves us with x squared. 25 divided by 5 leaves us with 5, and we are subtracting. Whatever's up here will go in here. Okay, last one. It looks like we have x's in both of these, and 3 goes into both of these. So we're going to divide both of these by 3x. Whatever's left will go in the parentheses. So we have 3's that'll cancel, and 1x, leaving us with x cubed. And over here, the x's cancel, and 81 divided by 3 is 27. So we've got x cubed minus 27. That is difference of cubes, and we will come back to that in a little bit. Okay, difference of squares. This works when your first term and your second term are both perfect squares, and in the middle you're subtracting. And when that's the case, you're going to have your first term in both of them and your second term in both of them, and you're going to subtract and you're going to add, not necessarily in that order. So for this one, our square root, or the square root of x squared, is x, and the square root of 4 is 2. So we are going to say x plus 2 and x minus 2. And the reason for that, if you remember from Thursday, when you take the square root of a number, the answer is going to be positive and negative 2. So we have x plus 2 and x minus 2. Okay, next one. This one looks a little messier, but 4 is a perfect square, x squared is a perfect square, 25 is a perfect square, and so is y squared. So when we take the square root of 4x squared, we take the square root of 4, which is 2, and the square root of x squared, which is x. When we take the square root of 25y squared, we're going to take the square root of 25, which is 5, and the square root of y squared, which is y. And now we can say 2x plus 5y times 2x minus 5y. And it is factored. And last but not least, this one, x to the 4th, the square root, remember you're taking half of the exponent, so it's going to be x squared. And then 256, if you remember the perfect squares that we've done up in the front of the room, is 16. So we're going to say x squared plus 16 and x squared minus 16. Okay, we're not quite done. This x squared minus 16 is still difference of squares. This is a perfect square, and 16 is a perfect square. So this one, square root of x squared is x, square root of 16 is 4. So we're going to repeat the first one because that one's finished, x squared plus 16. But then we're going to say x plus 4 and x minus 4. Now it's finished. Okay, simple trinomials. Okay, these are the problems that we started with the chart. So if you remember, it's the outside equals the middle. So we're going to say 1 times 15 is 15, and 8 is the middle term. And what we're looking for is two factors that give us 15 and add up to give us 8. So we could start with 1 and 15, and that would be 16, which would not be it. 2 doesn't go into 15, so we can go with 3 and 5. And when you add up 3 plus 5, you get 8. So that's what we're looking for. We're going to put these in the parentheses exactly the way that they are. So we're going to say x plus 3 and x plus 5. And we're done. Okay, next one. This one looks like it's confusing, but it works exactly the same way. So 1 times negative 6 is negative 6, and the coefficient of the middle term is negative 1. So we want two factors of negative 6 to add up to negative 1. So we could try 1 and negative 6, and if we add them up, we get negative 5, which doesn't work. We could try 2 and negative 3, and we add that up. We get negative 1, which is what we're looking for. So we're going to put them in the parentheses, a positive 2 and a negative 3. So x plus 2 and x minus 3. See, that wasn't so hard. Okay, number 3. We're going to say 1 times 28 is 28, and negative 11. So we want two factors of 28 that give us negative 11. So we could start with 1 and 28, which gives us 29, 2 and 14, which gives us 16. 3 doesn't go into 28, so we could try 4 and 7, which gives us 11, which is the right number, just the wrong sign. So we'll change both signs and make it negative 4 and negative 7, and that's going to add up to negative 11, which is what we're working on. So we have x minus 4 times x minus 7. All right, now perfect square trinomials. We didn't do these before, but now we can do them because we just did them on Thursday. So half the term is positive 2, and then we square it and we get 4. So that means this is a perfect square trinomial. So we can say x plus 2 squared, and we're finished. And these are so much easier now that we have done these for completing the square. Okay, this one, half of negative 14 is negative 7, and when we square it, we get 49, which is what we want, so we can say x minus 7 squared, which is also x minus 7 times x minus 7. And if you use the chart, it's still going to work. Okay, last one, and this one's ugly. Okay, so we get half of 1 is 1/2, and when you square it, it equals 1/4. So this still works. So we're going to say x plus 1/2 squared. Now this one would be harder to do with a chart. So this method of completing the square helps out considerably. Okay. Now we're going to use grouping. Anytime you have 4 terms, you're going to use grouping. We also use grouping when we get to complex trinomials because we create 4 terms. But we'll get to that in a minute. Okay, so what I want to do is put parentheses around the first 2 terms and the last 2 terms. Notice that that negative in front of the bx stays with the bx. Okay, so we can factor out an a here, Divide that by a, we get x. Divide that by a, and we get y. Okay, now we're going to do the same thing here. We can divide out a negative b, so we're going to put a negative b out here, and then divide that by negative b, and we get x. Divide that by negative b, and we get plus y. We want these two to be the same, and normally I go ahead and write this one down again, and I may do that on the next one. Okay, so now we're going to pull out the common factor, which is x plus y, and we'll cross that out, and we are left with a minus b. See? Okay, let's do the same thing with this one. Okay, so we're going to put parentheses around the first two and parentheses around the last two. That's our grouping. Now we're going to use the greatest common factor to pull out a y squared from here. So we're going to have y squared. We divide that by y squared, and we get y. Divide this by y squared, and we get negative 7. Then over here, we also want y minus 7. So if we multiply this by 4, then we get that 4y. If we multiply this by 4, we get that negative 28. So it must be a positive 4 that's in here. So y minus 7 is my common factor, and I can cross those out, and I'm left with y squared plus 4. And those are finished. Okay, complex trinomials. These are the ones that give people fits, but you guys were actually pretty good at this. So we're going to do the same thing starting out with a chart. We want the outside, so 2 times 2 is 4, and we want factors of 4 to add up to positive 5. So we can start with 1 and 4, and 1 plus 4 is 5. So we have it. Now, if we didn't have this 2, we could say x plus 1 and x plus 4, and we'd be done. But since we have that 2, we have to go through a couple more hoops. So we're going to take these two numbers, and we're going to rewrite this middle term. So it's going to look like this. 2x squared plus 1x plus 4x plus 2. Okay, everything is the same, except instead of 5x, I have 1x plus 4x, which is fine because 1x plus 4x is 5x. Now, don't combine terms, or you'll be back where you started. Okay, now we have 4 terms. And when we have 4 terms, we use grouping. So we're going to put parentheses around the first 2 and around the last 2. We're going to factor out an x. When we take an x out of here, we're left with 2x. When we take an x out of here, we're left with positive 1, which is what we want this other one to be. So we're going to go ahead and write 2x plus 1 on here. Okay, now 4x divided by 2x is 2. 2 divided by 1 is 2. So that means that we have a positive 2 out here. So we're going to take our common factor, 2x plus 1, and then cross it out. And what's left is the x plus 2. And that is a complex trinomial in factored form. Let's try that again. Okay, start out with your chart, because we need to know how we're going to rewrite that middle term. So 6 times negative 1 is negative 6. And then the coefficient of positive x is 1. So we can start out with 1 and negative 6, which is negative 5. We can do 2 and negative 3, which is negative 1. Right number, wrong sign. So we're going to change both signs here. We're going to make it negative 2 and positive 3. And that's going to add up to 1. And again, if we didn't have the 6, we'd say x minus 2, x plus 3, we'd be finished. But we do have the 6, so let's use these two numbers to rewrite that middle term. So 6x squared minus 2x plus 3x minus 1. Parentheses around the first 2 and around the last 2. We can pull out a 2x from the first one. If we divide this by 2x, we're left with 3x. If we divide this by 2x, we're left with 1. So it's going to be minus 1, which is what we want the other one to be also. Okay, 3x divided by 3x is 1. Negative 1 divided by negative 1 is 1. So this must be a positive 1. So we're going to write down the common factor, which is 3x minus 1, and cross it out. And then the rest of it, 2x plus 1, is going to be our other factor. And voila! We have 2 complex trinomials factored in no time flat. Okay, sum and difference of cubes. I don't think we've done these too much, but we have a pattern up here. And it's kind of like difference of cubes, except that in this case they're added and they're perfect cubes. And so this is kind of strange. We're going to take the cubed root of each one, and then we're not going to use that anymore. We're going to square this first number, we're going to multiply them together and change the sign. And we're going to square the last number. So it looks like this. We have the cubed root of x cubed is x. The cubed root of 8 is 2, because 2 times 2 times 2 is 8. All right, so we have our short parentheses. Since this is plus, it's going to be x plus 2. And then we have the long parentheses. And we're not going to use this anymore. We're going to square the first term, which means x squared. We're going to multiply these together, so that's 2 times x is 2x, and change the sign, so it's minus 2x. And then we're going to square the last term. 2 times 2 is positive 4. And that is finished. Okay, let's try the next one. So this number is a perfect cube. Cubed root of 27 is 3. Cubed root of x cubed is x. Cube root of 1 is 1. So we're going to say 3x plus 1, and that's in the short parentheses. Then in the longer parentheses, we have 3x squared, so 3 times 3 times x, so 9x squared. We multiply these together. 1 times 3x is 3x, and change the sign, minus 3x. And then square the last term. 1 times 1 is 1. And that is sum of cubes. Now, if you can do sum of cubes, you can do difference of cubes, because it's exactly the same way. So we're going to take the cubed root of x cubed, which is x, the cubed root of negative 27, which is negative 3. And then we're going to say x minus 3 in the short parentheses. In the long parentheses, we're going to square the first term. So x times x is x squared. We're going to multiply these together. Negative 3 times x is negative 3x, and we're going to switch the sign, plus 3x. And then we're going to square the last term. Negative 3 times negative 3 is positive 9. So x minus 3 times x squared plus 3x plus 9. And don't even ask me how they came up with this. Apparently some mathematician who was bored on a Friday night did 50 million of these and noticed that there was a pattern. Okay, last one. Cubed root of x cubed is x. Cubed root of negative 64y cubed. Let's do it a little bit at a time. So the cubed root of negative 64 is negative 4. And the cubed root of y cubed is y. So we're looking at x minus 4y in the short parentheses. Then in the long parentheses, we've got x times x, which is x squared. Multiply these together, and we get negative 4xy. So we're going to make it positive 4xy. And then finally, we're going to square the last term. So negative 4y times negative 4y is going to be positive 16y squared. That almost didn't fit. And we are done. All right, your assignment is the 10-2A factoring review worksheet. So it follows this, as in you'll be looking for a greatest common factor, difference of squares, simple trinomial. So you're going to follow these in order to do that. Good luck with it. Thanks.